7.3, guys, we talked about power functions and function operations. We're going to start with function operations. I'm going to play with some power functions too. And I am on page 415, and you have all of there how it works when we add two functions, when you subtract two functions, and we'll actually do it physically here so you'll know how it works. But when we add them, we just put them together and we add apples with apples, oranges with oranges, and so forth, right? When we subtract, we do the same. When we multiply, we're going to distribute the right way. And then for division, if we can, we are going to reduce. If we can't, we're not going to reduce. Example 1. We have f of x of 2x to 1/4 and g of x of negative 6x to 1/4. They're asking for the sum, they're asking for the difference, and they also want to know what is the domain of each one of them. So let's do the sum. I have 2x to 1/4 plus negative 6x to 1/4. Literally, we have 2 apples plus negative 6 apples. This is negative 4x to 1/4. We just add them up. They're the same kind. This is what we get. 2 plus negative 6 is negative 4. That just follows through, right? We're going to deal with domain in a second. Let's look at the difference. This becomes 2x to 1/4 minus negative 6x to 1/4. Because I'm putting instead of f of x of whatever that is, instead of g of x, whatever that is. Minus minus become plus. I have 2 apples plus 6 apples. There's an 8x to 1/4, 8 apples, right? If I'd have to plug this in and go to y equals in order to find our domain, this is the fastest way to do it. I go negative 4x raised to parenthesis 1 divided by 4, and I go zoom 6, and I graph it. What is my domain? It starts at 0 and it goes to positive infinity. So this is, my domain is x greater or equal to 0, right? It starts at 0, it shows me where it starts, and it goes to positive infinity. If I do the second one, this becomes, instead of negative 4, I get an 8. And then I do zoom 6 again. Yes, it goes on the top, but again, it starts at 0 and it keeps going. My domain is x is greater or equal to 0. That's how I know it starts at 0 and I can't see where it goes, right? And that was your example 1. Example 2 deals with multiplying and dividing fractions. F of x is 3x, g of x is x to 1/4. Let's replace them. Instead of f of x, I have 3x times g of x, x to 1/4. This is the rules of exponents. Same base, this becomes this becomes 3. X to 1 plus 1/4. If you need to use your calculator, do it. This is 5/4. How do I know this? I can write this as 4/4 plus 1/4, 5/4, right? When we do the division, this becomes 3x over x to 1/4, or 3x to 1 minus 1/4, right? I have x to first power over x to 1/4. The rule of division for exponents, it's 1 minus 1/4, 3/4, right? That's what we get in here. Now they want you to do the domain and the range of all of them. We're going to go ahead and look at the domain of y equals 3. Let me clear this out. 3x all to the 5 divided by 4 in parentheses. Please remember to put your exponent in parentheses at all times. Zoom 6. Here's my graph. All of my positive numbers, right? I get, well, let me look at this and make sure that I have a negative there. That is incorrect. I'm sorry. Zoom 6. So if you look at your domain, all positive numbers starts at 0 and it goes over there. So this is x is greater or equal to 0, including 0. For my second one, if you put it in, you're going to get the exact same thing. But I want you to think about it. Why did I not put equal there? We talked about this in class. This value can never be 0. You can't divide by 0, which means x cannot be 0 at any time. So for my domain, for my division, x has to be greater than 0, not including 0, because this cannot be 0, right? So we dealt with multiplying, division, adding, and subtracting fractions. We are now doing composition of functions, and if you look at page 416, I'm going to explain to you how that works. And basically, when you compose functions, you go, this is my f of x, this is my g of x. What is my f of g of x? Which means, the way we're going to write this, when I write 3, and instead of that x, I'm going to write that g of x. 2x minus 1, all to the negative 1. We know the property of a negative exponent. This becomes 3 over 2x minus 1. Right? In order to become positive, it needs to go underneath the fraction. So instead of just writing x, instead of that x, I plug this g of x there and then follow it through. What is g of f of x? Well, this becomes 2. Instead of that x, now I'm going to write f of x, 3x to the negative 1 minus 1. So this becomes 6x to the negative 1 minus 1. And if you look at the book, they don't necessarily leave it there. They go 6 over x minus 1, so we don't keep negative exponents. If it's a negative, it goes underneath the line and it makes it a fraction. And now they want to know what is f of x, which means I'm going to write 3. And instead of x, I'm going to write again 3x to negative 1, and all of it to a negative 1, right? 3x to negative 1, all of it to the negative 1. Let's look what we get here. We get 3 times 3 to the negative 1 times x to the negative times a positive to a first property. 3 to the first times 3 to the negative first. I can apply the rules of multiplication. This becomes 3 to the 0 times x. Any number to the 0 power is 1, so this is simply x. They're going to ask you what is the domain of each one of them. They're not that hard to figure it out. Look at this one. In order to figure out the domain, I know what x cannot be. This bottom, 2x minus 1, cannot be 0, which means x cannot be 1/2, right? So if I would have to graph this, I can graph it and I'll see this is all real minus 1/2. Okay, if I put that into a calculator, I'll get a graph that's going to kind of go right around that. If you look at this, I already know x cannot be 0, so the domain of this is going to be all real, all of it minus 0, right? Because that would make that non-existent. For the third one, we have all reals if I would have to graph it, because y equals x is just a line that continues. So this is all real numbers. So when they ask you for your domain, the easiest way for you is to graph it and see what that is. If I go to graph and I just graph the first one, let me clear it out. I get 3 divided by, I'm going to open parentheses for this, and I told you this in class. Please remember to always keep parentheses when you have more than one thing on the bottom. 2x minus 1, and then I go zoom 6, just for you to see how it works. There's my graph. You see how it goes right around that line? I know my domain is all of the values possible except for that 1/2, right? And that's how you graph each one of them. That's how we find composition of functions. We have a word problem that we're going to deal with. It tells us something about biology. L of m is 12m to 0.217. And then I have another function that is incubate. So L, oh, it's I. It's incubation. It's not L. It's I, incubation time. And then we also have the water loss during incubation, Rm, which is 0.015 times m2, 0.742. They're asking us how you can use the two-part function models to verify your conjecture, because it says your conjecture that proportion of water loss during incubation is about the same for any egg site. So really what we want to know is what is the proportion of water loss, which is, if you look at your a verbal model. I'm not going to write it all down. It takes me forever. It says it's going to be the daily water loss times the number of days over the egg mass, right? And we know what the daily water loss is R. We know the number of days is your incubation, and the mass is M. So this becomes my model is RRM times I of M. Here's the great news. All over M, you don't have anything like that in your homework. So I get to times the two of them. I go numbers with numbers. So I'm going to go 0.015 times 12, which gives me 0.18. M to the 0.217 plus 0.742, 0.959, all over M. And if you remember, this is the first power. M over M, this becomes 0.18. M2, what is that number minus 1? Negative 0.41. Negative 0.041. Why I get this one minus this one is the property that deals with division. We have the same base, we subtract exponents, right? And that's where you stand right there. If you put that in there, you go, if you raise that to that power, you get about 0.18. And if you look at that, the water lost about 80% of any bird size eggs, which proves your conjecture is correct. It's just really put in words. Did not do that to you on your homework. And we also have a other word problem that deals with selling clothes, which I think we like that. It says the clothing store advertises that it's having a 25% off sale for 1 day only. The store advertised an additional 10% savings. Use the composition of functions to find a total percent of discount. What would be the sale price of a $40 sweater? So if we say that we have a 20% discount, my f of x would be whatever that price is, x minus how much is my 0.75, 0.25 of that. I have a problem writing numbers today because we're taking off 25%. So really my initial sale is 75% of any price represents my initial reduction. But then it says the reduction price for initial 10%, you can write that as g of x is x minus 0.10x or is 0.90x. Okay, that's your additional percent. What we want to know is what is g of f of x, because we want to know the final reduction. So this becomes 0.90 times, instead of x, I'm going to write f of x, 0.75x. We do that in the calculator because we like that, and that becomes about 0.675x. That is the composition model, okay? This is your second edition clearance, and then we want to know with that clearance what is the price. And they say, what is the price when x is 40? Well, that becomes 0.675 times 40. You put this in the calculator, you get an approximately it's not approximately, it's exactly $27. Now, there would have been another way to do this would have been to $40, take 25% of it, which would have made it $30, right? And then out of that $30, you get another 10%. 10% of 30 is 3. 30 minus 3 will get to 27. This is the long, complicated way to solve problems. The other one would have been to go step by step and solve it that way. But that's about this little 7.3. Good luck with your homework.